Now I would like to introduce something else on that same beam, something that we're calling a couple. Now a couple is defined as two forces having the same magnitude and parallel lines of actions and opposite sense. Now in this situation, the sum of the forces in each direction is 0. So a couple does not affect the sum of forces in the equations. However, the couple will tend to rotate the body it is acting on. Now, if I were to show you my couple on my beam here, I have a beam AB of length 3 meters and it has supports at the two ends where we have reactions RA and RB. And then we have introduced a couple. Now a couple is denoted by this symbol just to show you the two parallel forces. You can see they have two lines of actions and the couples are opposite, or they have forces that are acting opposite to each other. That is, they have the opposite sense. And then the forces have to be of the same magnitude. So we're saying that the sum of the forces in this case in each direction is 0. So the couple will not affect any forces. Should we have a point load somewhere here, in our case, when we are adding the sums of the forces, we would not add the couple to it, because we're saying that the sum of the forces in each direction is 0 because they cancel out each other. However, the couple will tend to rotate this beam. Like in this case, the couple will tend to rotate our beam anti-clockwise. So when we are dealing with a couple, say for example in this case we are asked to find the reaction RA. So we can choose to take either side. Then you can say taking moments about A according to the principle of moments, then the total clockwise or sum of clockwise moments should be equal to sum of anti-clockwise, is it? Therefore, we have moments about A. So we're trying to take the moments that are turning this thing clockwise. Remember, I had just drawn this for explanation purposes. So if we are going about A, is there anything that is trying to rotate this beam clockwise? In our case, there is none. So 0 should be equal to the moments that are turning our beam counterclockwise or anti-clockwise. So in our case, we have RB trying to rotate our beam upwards, acting at a distance of 1.5 plus 1.5 from point A, that is 3 meters, plus our couple. Remember, our couple already has you can see the couple already has been multiplied by a distance. Therefore, the couple, or the effect of the couple, is equal all along the length of the beam. Whether it is here, here, or here, it does not change. Therefore, we add the couple just as it is, 5 Newton meters. So to get RB, we have 0 is equals to 3 RB plus 5. So 3 RB is equals to negative 5. Therefore, RB is equals to negative 5 over 3, which should give us a negative 1.667 newtons. Now, let us take moments about point B. So when you're about point B, we know the sum of clockwise, again applying the principle of moments, should be equal to sum of anti-clockwise. So the clockwise moments about point B are 1, RA is trying to rotate our beam clockwise. Then RA acting at a distance of 1.5 plus 1.5 should be equal to it is the only clockwise moment, should be equal to the anti-clockwise moments. Now in this case, the couple is the only thing trying to rotate our beam anti-clockwise, should be equal to the 5 kilonewton meters. Therefore 3 RA is equals to 5. Therefore RA should be equals to 5 over 3, which is equals to 1.667 newtons. Now, to confirm whether we have the correct values, we can apply the second rule that says that sum of upward should be equal to sum of downward forces. Which are our upward forces? RA plus RB should be equals to RA plus RB should be equal to the sum of the downward forces. Remember, we said that number 2 here, the sum of the forces in each direction is 0. So a couple does not affect the sum of forces in the equation. So therefore, the sum will not exert any force downward or upward. Therefore, we have no forces acting downwards on this beam. Therefore, it is 0. Where is our RA? RA is 1.667 minus plus RB is minus 1.667 should be equals to 0. Therefore, 1.667 plus our RB, which is negative 1.67, should be equal to 0. Therefore, this confirms that indeed our answer is correct. So you can go ahead and look at the other worked examples on the handout that I sent you, or the book, or I will send you the extract of that book, but they will not be the same. So should you have had another point load here, remember it would not have changed anything, otherwise you would have had another counterclockwise force or clockwise, depending on which direction you are taking moments about. But then when you're equating the upward and downward forces, you would have an extra force here to equate here. So there's no big difference. Try and work out in the next examples, and then when we meet next time, we can discuss where you're finding challenges. Thank you for your patience, and see you next time.